So today we are going to start with columns, design of columns. You all know this is coming under unit 4 of your particular syllabus. Here it is written as 6, but in your syllabus, as per 23 regulation, it is coming under unit 4, right? So you know what is a beam, what is a slab, and what is a column. So column is a compression member. You should not say as a vertical member. Vertical member is all the vertical member are not termed as column. So it is a you have to define with respect to the load that is being carried by the member, right? If the beam is carrying the load, it will carry along the longitudinal direction. So that is beam. First column, it is carrying a compressive load. And what code has defined a column be precise is the effective length of the column exceeds 3 times the least lateral dimension. இங்க ஒரு 3 டெக்னிக்கல் வேர்ட்ஸ் இருக்கும். உங்களுக்கு ஆல்ரெடி தெரியும். Just I'm giving an quick introduction. So effective span is a one technical word, and least lateral dimension is another one, and a compression member. These are the three technical terms that a civil engineer must know. So if you are going and asking somebody what is a column, oh, even a layman can answer. Whatever the pillar or the vertical member, they can easily term it as column. But you, as a civil engineer, you must be aware of these three things. A column is a member which is carrying first compression load, compressive load. That is one thing. And what is precisely defined a column is the least lateral dimension. Lateral dimension is the thing, nothing but if I draw a column, right? If I'm drawing a column here, okay, on a rectangular column, I'll take this 1 minute. Okay, getting edited version is not there. So just assume a rectangle section, right? Say 200 mm by 300 mm, 200 cross 300 mm, right? So this is the lateral dimension. And what is the other dimension? Height. When I say column, when I say member, it has three dimensions. One is length, another one is breadth, and depth or width, right? When you go for a beam, you'll call it as a depth. As far as column is concerned, we'll consider as a width and breadth. So three dimensions we have. So here the least lateral dimension. Lateral is nothing but the other direction. One is a vertical direction. The other two directions are lateral direction. So lateral direction is 200 by 300. I'm not considering the height of the column here. So what they are saying here, the height of the column is given as effective length. So the effective length height must exceed 3 times the least lateral dimension. Least is nothing but when I have two different dimensions, 200 by 300. We can have 300 by 300 or 400 by 400. Anything is fine. But 400 by 400 both are same, right? B and D are same, right? So I'm taking an example, 200 by 300. Among these two, which is least, 200 is least dimension. So that least dimension multiplied by 3. 200 into 3, I'm getting 600 mm. So that 600 mm must be less than the length of the column. That is, the effective length of the column must be higher than these 3 times the least lateral dimension. This is a very common definition for a column from civil engineering perspective, right? So here I have given explanation for least lateral dimension, and I have given explanation for compression member. What is called as effective length? Okay, so when I say height, you take an example of a human. I'm taking an, or if I'm asking you what is your height, if they are saying 5 feet 3 inches or 5.6, 5.7, this is the total height. If I'm asking, say for example, I'm asking what is the effective length of your, so what is the effective height of a person, right? If I am saying effective height, what I mean here is among your 5.6 or 5.3, whatever the height you have, there are some part, till some part, I am using that as the effective one. I'm not saying you take an example of a human. I'm asking effective height means it has to be from the neck to the toe. That is the effective height. அப்படின்னு நான் சொல்றேன் அப்படின்னா, it doesn't mean that I'm not considering the head. Head portion is not an effective one. Not so. But what happened is that head portion is been linked with the support. So that particular part will be taken care of the taken care by the support. The remaining distance or whatever the effective portion is called as the effective length. So how do you calculate this effective length? And next the question rises like that. So how do you calculate the effective length of the member? So if you go to IS 4 Annexer E, here they have given very clearly the heading itself. They have given effective length of the column. Right. Directly go to the next page. You have a table over here in page number 94. Table number 28. Here you can see what is the effective length of the member. Say L is your normal length, then LE will be your effective length. Based upon the support condition, if both the supports are pinned, both the supports are fixed, or one end is fixed and other end is free, you can take the recommended value for effective length here. The fourth column value we can take. For example, the length of the column is 3 meters. Then for this condition, effectively held in position and restrained against rotation, both the ends are fixed condition, then you go with the LE will be 0.65 times L. So L 3 meters, so 3 into 0.65, whatever you are getting, that will be your effective length. That's all, very simple. This will be useful in for all the problems for calculating the effective length. Right? I hope it is clear. So I'm just giving an introduction about what a column is all about and how do you define a column. Going on with quickly, as this is a revision sessions, I'm quickly going on with the next classifications part. So you can easily classify based on the shape, what type of shape it is all about. And next, based on the slenderness ratio, I'll come to this part now later. I'll finish off the easiest part first. Then based on the um, reinforcement that I'm going to give, whether I'm going to give the reinforcement in a tight manner or if I'm going to give the reinforcement that is lateral reinforcement along like a spherical one, which is mostly for a column of circular section. Then based on the loading, this diagram easily explains what is all about loading, axial loading. So the load will be acting exactly at the centroid of the column, concentric load. Then that is called as axial loading. Then it is acting at a distance of some distance of E, which we call it as eccentricity. That is E. So then if it is acting along one eccentricity for only one direction, then it is uniaxial loading. What happens if I am having a load away from the center? There will be a distance. So because of the distance, I will get a moment. You know what is the moment? Load into perpendicular distance. So I'm getting a distance over here. So load and distance. So this creates moment in addition to the loading. So uniaxial compression loading or compression type. So uniaxial bending. Then if the load has been acting along both the axes, that is load is not concentric or center with respect to both the axes, then we'll call it as a biaxial. This is on another type, axial, uniaxial and biaxial column. So here also you can see here. So if it is axial, we'll have only PU. If it is uniaxial, I have load plus moment along any one axis. It may be X or Y. The next one is load plus two axis moment. So MUX and MUY. And based on material, you can say what type of material it has been made up of: timber, stone, masonry, RCC, PCC, steel, or aluminum, or any type of composite column. So that we can say based on the material. Right. The one which I have left now is I'm addressing that. One is long column, another one is a short column. So which column is called as long and which column is called as short? Right. It's very basic classification of column with respect to the slenderness ratio. That slenderness ratio will call it as L by D ratio. L by D. When I say L by D, you will ask which direction, right? So it may be L by D or L by B, any direction, because if the column size section is not symmetrical, that is not 200 by 200 or 400 by 400, instead of that I'm getting 200 by 300. One side is 200, the other side is 300. Like here you can see it's a square column, this is a rectangle column. You can assume the value here as like 400 and this will be 200, right? So based on these conditions, so it will be a slender ratio is nothing but the ratio of length to the least lateral dimension, or sorry, no, not least lateral dimension. I'm begging your pardon. Lateral dimension, length by lateral dimension. Then what they are saying may be considered as column, which can be considered as column. The compression members can be considered as column when both the slenderness ratio, that is Lex by D and Ley by B, are less than 12. When L by B ratio or L by D ratio is less than 12, then we call it as a short column. So less than 12, so lesser, short. If it is greater than 12, then it is a long column. That's all. Very, very simple. Here you will have a doubt. Lex divided by B or Lex divided by D. How to remember this? Which one has to come first, right? Yesterday we have seen Lx, Ly. I remember for a slab. When I say 3 by 3 meter by 5 meter slab, which is Lx and which is Ly. 3 meters is Lx and 5 meter is Ly. This is what we have seen yesterday. As far as column is concerned, whichever is higher, right? Again, take an example of 200 by 300 mm. 200 mm by 300 mm, which is higher. 300 mm is higher. So that is taken as the major axis. That is taken as the D. The lesser is taken as the width. Here you can see it is taken as B, width of the member, whereas D is taken as the depth of the member. Depth or width, breadth. Here to address this, they have taken it as a depth. So Lex by D, X direction, it has to be the major axis. So D will be higher. Ley by B, the lesser direction, we call it as width of the member. Both the ratio has to be less than 12. Even if any one direction exceeds, any one ratio exceeds 12, then it is not a short column. So pretty clear. So you know what is slenderness ratio? A ratio of length to the lateral dimension. So when I say lateral dimension, we have two sides. So one is B, another one is D. Which can be taken as B, which can be taken as D. The higher has to be taken as D, that is major axis. The lesser has to be taken as the minor axis. It has to be B. So you just put Lex by D and Ley by B. You will get the number. Check whether it is greater than 12 or less than 12. You name it whether the column is short or higher. Lesser, short, greater, it is long column, right? Okay, done. So these are the classifications. So I'm just quickly moving on with the problem. I don't want to get waste your time more. As this is a revision session, so I'm quickly moving on with the problem. Please keep it in mind. These four problems are very, very simple and easy to understand. You have a code book to solve this, very less time consuming. So please concentrate on just four types of problem. Please easily you can understand. One is load carrying capacity. You have to find out the column load carrying capacity, how much the column can carry the load. When I say how much the column can carry, you can assume the what will be the given data. What will be the given data? NLR given data, size of the column will be given, right? Then what will be given? Load கொடுத்துட்டாங்க. If I'm asking you how much weight you can carry, what you will ask? You must know what is the dimension, what you have been made up of. So grade of materials, what grade, okay, that has to be given. Then what is the next thing? You have to say the height of the column, right? Length of the member, you must know what is the length of the member. Then what else? Length of the member. That's all. These are the very basic three datas you must have with you. Yes, I'm just addressing for the sake of how to understand the problem, what they have given. Because without understanding what type of problem is given, blindly, if you are copying from somewhere like code book length, irrespective of the questions and irrespective of the table you are choosing, no use. You must understand what they are asking and what you are supposed to give. That is very, very important. Okay. So this is one type. Please have a clear understanding what is being asked. What is being asked here? You are supposed to calculate the load carrying capacity of the column. That's the point. Okay. Then these three types are what do you call design problem. These three types are call it as design problem. These three. axial, right? Axial, uniaxial, and biaxial. These three are not okay. Thank you, Kaushik.
Yes, sir. Yes, sir.
Okay. Okay. Next, okay, these three types are called as is for compression. Sorry, design problems. So one is axial compression, another one is uniaxial compression, and another one is biaxial compression. So when I say you are supposed to design, so what you have to find? These are the things are given here. You are supposed to find few things. What are the things you have to find? When I say design, you have to fix the size of the column. You have to fix the size of the column. Next thing, what is the next thing? When you fix the size, you have to fix the reinforcement. These two things you have to fix it. So that is what called as design. Here, your given these are the given datas. These are the given datas you are supposed to give. Given, and you are to calculate the load carrying capacity. Here, you have to find the size of the column and reinforcement. Then tell me what will be the given data. What are the given datas will be? So given datas will be again grade of materials, that is common. Grade of materials is common. Then load will be given. That is what important. Load is given. So you can understand now. You can very well classify this. First type of problem is you have to find the load carrying capacity. Go to the question. You understand what they are asking. Determine the load carrying capacity. Determine the capacity of the column, or find the load that the column can carry. All those stuffs. The question is very clear. If it is given, if it is asked, load carrying capacity is asked, then the given will be size of the member, grade of materials, and length of the member. These are the given data. When you find a word called as design, right? When you find a word called as design, then it is you have to design it. When I say design, you have to design two things. One, you have to determine the size of the column, and you have to reinforcement. You have to give the reinforcement. How much bar has to be given? What is the size of the column has to be? You have to fix it. That is what design is all about. So if I say how much amount of reinforcement has to be given, then I must be aware of what type of load it is being carrying. So load has to be given. Question load இருந்துச்சு அப்படின்னா it is design. Question load இல்லைன்னா it is load carrying capacity analysis. This part is called as analysis part, and this is called as design part. Do you have any clarification on this? Because without understanding this, we cannot proceed further. First is this analysis part. Another one is second one is this is analysis, and this one is design. Do you have any doubts on this? இப்ப ஸ்கிரீன் தெரியுதாப்பா? எழுதுறது டைப் பண்றதெல்லாம்
Yes, sir.
வருதா?
Yes, sir. No doubt.
Okay, fine. So just only we have two type of problem. One is analysis, another one is design. That's all. Okay, if analysis part will be very shorter, just one formula you can directly so put it and you can solve it. I'll show that where you can find the formula. Yes, time. Yes, here you can see page number 41. Yeah, you can see compression members. They are giving what is a column. We have just discussed exceeds 3 times. So you can directly define this from the column. and what is slenderness ratio they have given. Okay. Then moving on with the unsupported length. What is the unsupported length, and what is the slenderness ratio limit for a long column and short column they are given. What are the detailing things for the member, that also you can identify from here. Moving on with the design in a minute. Very important task is for you will be identifying the design parameters or the design guidelines from the code book, where it will be, right? Where you can easy to see. I'm using here the find function. That doesn't mean that I'm doing it easily. No, that's not the case. Even you also find it easily from the table of contents. You can easily bring back all those stuffs. Okay, fine. Moving on with the formula. So if if you are supposed to analyze, if you are supposed to do the analysis part, that is first type, this type of problem, then you have to find the load carrying capacity. To find the load carrying capacity, the formula is given here. PU is equal to zero point 0.4 FCK plus, sorry, FCK into AC plus 0.67 FY into AAC. Here where you will get confused is AC and AAC. What is AC? Area of concrete. C stands for concrete. And AAC, area of steel in compression. So area of steel in compression, when I say it's a reinforcement. So when I say column of 300 by 200 mm or 200 300 mm, that area 200 into 300 will be 6,000. So 6,000 will be your gross area, entire area. Adula, what is the amount of concrete present? What is the amount of steel present? That you have to split up. Okay, that you have to split up. What is the amount of concrete in sorry, what is the amount of, yes, what is the amount of concrete in the gross area? What is the amount of steel in the gross area? That is what AC and AAC, just substitute the values, just substitute the form values, and you will get the answer. That is P equal to 0.4 FCK plus 0.67 FY AAC. Yes, very simple. Just a substitution. Only thing you have to calculate here is from AG you are supposed to calculate AC and AAC. In problem, I'll show a problem. You will get to understand what it is very clearly. So the procedure is only one formula. Just use this formula and find out the answer. That's all. Very simple. Moving on with the design problem. So design problem da romba important. That is very important than the load carrying capacity. That doesn't mean that load carrying capacity will not come. I'm not saying that. It's a very easy problem. It's just one step problem. So you may get it in 2 marks or 6 marks or 8 marks, whatever. Whereas design problem is a pure and pure 16 mark question. So you will get design problem. I recommend you to study both analysis and design, because based on the time constraint, you can easily undergo, or you can take up whichever problem you want. Okay. Then I'll go through the steps first. Then I'll show a problem. It will be easy for you to understand and relate it to it. At this moment, how many are present? Okay, I see 14 members. Fine. Fair enough. 50 percentage. Okay. Okay, what is the key step? First, you have to calculate the effective length. You know how to calculate. Just now I have shown table number 28. From there, you can calculate the effective length. Yes, based on the support. You can calculate, right? Yes or no? Effective length from table number 28, you can easily calculate. You know the length, whatever they are given. Just take the support condition. Enna support condition பாருங்க. The number value அவங்க கொடுத்திருக்க போறாங்க. அதை வச்சு you can do it. Right? First step is clear. I have already explained. Second step, slenderness ratio. What is slenderness ratio? Just now I said. What is slenderness ratio? Length to the dimension. So LEX by D and LEY by B. So based on that, LEX and LEY, why I'm saying X and Y is both the direction length will be most probably same. So you can take the same length. So the B and D will gets differed. So that is the slenderness ratio. Then what is eccentricity? So eccentricity is something, the point of load acting away from the center. That's the distance from the center, so that the load is acting based on uniaxial or biaxial, or it is eccentricity is minimum eccentricity. Right? Next one is load carrying capacity. From the formula just now I showed, you can calculate the load carrying capacity, or the load is given, then from there you can calculate the ASC. Very simple. LHS and RHS. What is LHS? Load carrying capacity equal to Here you can see. Yes, LHS is PU, that is load. The rest of the thing is RHS, it will be concrete and steel. First part is concrete part, this part is the steel part. Okay. So whatever been asked, if you are you are supposed to find the LHS, then use the formula directly. If you are supposed to calculate the RHS, then LHS will be given. That's what I said. LHS will be given here. What is LHS? Load carrying capacity. Load is given. Okay. Then you have to find out the size of the column and reinforcement. Size of the column என்னது AG இல்லையா gross area. Gross area எங்க இருக்கும் கான்கிரீட் ஏரியாவையும் ஸ்டீல் ஏரியாவையும் ப்ளஸ் பண்ணா கிராஸ் ஏரியா இருக்கும் கரெக்ட் தானே ஸோ அப்போ அது ரெண்டும் ஆர்ஹெச்எஸ்ல இருக்கு ஸ்டீல் ரீஇன்ஃபோர்ஸ்மெண்ட்ன்றது என்னது இதுதான் ஏஎஸ்சி கரெக்ட் ரைட் ஹேண்ட் சைடில் இருக்கு ஸோ எல்ஹெச்எஸ் தெரியும் இதை வச்சு ஆர்ஹெச்எஸ் கண்டுபிடிச்சிடலாம் இன்னொரு சம்மில் ஆர்ஹெச்எஸ் எல்லாமே கொடுத்துருப்பாங்க எல்ஹெச்எஸ் நீ கண்டுபிடிக்கும் அவ்வளோதான் இந்த ஒரு ஃபார்முலா தான் ரைட் ஓகே ஸோ லோட் கேரிங் கெப்பாசிட்டி அதில் ரீஇன்ஃபோர்ஸ்மெண்ட் தென் கோ வித் தி lateral ties and reinforcement diagram. Lateral ties and reinforcement diagram you can directly follow from the code book. It is very clear. They have given proper guidance for on determining the lateral dimension, what has to be given, what not to be given, what is the limit, 300 குள்ள இருக்கணுமா 400 இருக்கணுமா 450 இருக்கணுமா அப்படின்றது everything they have given clearly in the code book. Once I'll start the design problem, you will understand that. Okay, then this is for a axial column. When you come for a biaxial or uniaxial, right, bending, uniaxial column, uniaxial bending and biaxial bending, the same step will be followed. What effective length will be followed? Slenderness ratio you have to find out, eccentricity you have to find out, the load carrying capacity formula that you are using here, right, this one. Instead of this, I'll be using the chart. I'll be using the chart that is given in table number, from table number 27 chart says compression with bending. Compression with bending. From here on, you can take up the values and you can calculate this value, that is PU by FCK BD and MU by FCK BD square. This is called as non-dimensional parameters. There is no dimension, there is no unit for it. So from these two values, you get this. This is nothing but P by FCK. Of steel divided by FCK, grade of the concrete. So you know how to identify this. We have done it in class, and you also given a lot of input on this, which is very clear and which is very close to it. So you can take the value that will be P by FCK. FCK, you know the grade of concrete. If you substitute, you will get the PT percentage. So when I say PT percentage, it is 100 AST by BD. From there, you can calculate the AST. It's all very simple. So you'll get the reinforcement, lateral reinforcements, lateral ties and reinforcement diagram. No difference. The only thing is load carrying capacity. You can use formula. Here they are using the chart. That is SP16 chart. That's the only difference from these two. Okay. So I'll quickly brush up the problem. I'm not going to take up in detail. Just I'll give the only the glimpse of the problems, because we have done enough already in class. Yeah. So I'll directly go with the design problem. I'll directly go with the design problem here. Yes. Just read out I'm reading out the question. Just understand this is a problem on analysis. Okay, analysis now you have to calculate the load carrying capacity, right? So what they have given, the rectangular column of size, they are given 400 by 550, and support condition is fixed at one end and hinge at other end. So unsupported length. Okay, we are talking about so far effective length. So what is the other one? What it is given is the unsupported length. That is L. This is L. You have to calculate LE. That's the only thing which I have not addressed here. That is unsupported length in Ravati and I so far use panel. So the given question என்ன இருக்கும் அப்படின்னா unsupported length இருக்கும். நீங்க calculate பண்ணது effective length, right? Okay, determine the slenderness ratio of the column and state whether the column is long or short. You are just supposed to say whether the column is long or short. So for calculating the effective length, the formula from the table, from the code book, it is 0.8 times L. From table number 28. Okay, so they have calculated and they have doing LE by D. LE by D, it is 6.1, and LE by B, it is 8.4. Both are less than 12. Then the column will be short column, right? So this may come as a 2 mark or 3 mark, wherever. So very simple. Just you have to substitute it, right? Just next, moving on with the direct determine the strength. Yes, here a column 600 by 400, 3 meter long, effectively held in சொல்லிட்டாங்க. So no need to calculate effective length அப்படின்னு கிடையாது. புரியுதா? effectively held தான் சொல்லியிருக்காங்க. Okay, not they are saying the length is 3 meter long is effective length. No, you will get misunderstood. 3 meter long effective. This doesn't mean that the given length is the effective length. No, effective length is not given. If at all, they'll say effective length of the column is 3 meters. They won't say 3 meter long. 3 meter long. The question has to be comma. Effectively held in position and restrained at both the ends. Both the ends are fixed. That's what they are saying, right? So they are given the reinforcement, 6 numbers of 22 diabar, grade of steel and grade of concrete is given. You are calculate the strength. That's what I said. Load in சொல்லலாம். Okay, load carrying capacity in சொல்லலாம். Strength in சொல்லலாம். Whatever they can say. Okay, axial, what is the axial load? What is the failure load? All those stuffs is very simple. Just understand from the question what is given, size is given, so no need to find out the no, it's not a design problem, it's an analysis problem. That's what you have to keep it in mind. Okay, size of the column AG, 600 by 400, and ASC, they are given 6 numbers of 20 diabars. So 6 into pi by 4, 22 square, you will get the ASC, right? Both the ends are fixed, so effective length will be 0.65 into 3,400, or sorry, 1950 meters. 1950 not meter. Okay, then you just check whether the column is long column or short column. Yes, now the important part comes here. What is the eccentricity? What is the eccentricity? This is there in the code book. They have given the eccentricity in words here. The member shall be designed and the minimum eccentricity. When the minimum eccentricity as per 25.4, you have to go to 25.4. Yes, here 25.4 minimum eccentricity is given. So what they are saying, all the columns shall design for the minimum eccentricity equal to unsupported length. Again, here it is very clear. It is the unsupported length, not the effective length. Please keep that in mind. Just follow the code, what it says. Nothing to by heart or nothing to remember here. Just follow what code says. So unsupported length of the column divided by 500 plus least lateral dimension, sorry, lateral dimension by 30. One, this has to be there, or another one is subject to minimum of 20 mm. இந்த ரெண்டு condition மட்டும் you have to check it, right? So that is what it is highlighted here. So L by 500 plus D by 30, I'm getting 26 mm. And another condition you have to check, it is 0.05 D, 0.05 D times the length. Let me check. So not the length, D, the maximum dimension, which is given in the words here. Yes. So again, coming back to the design part, the member designed shall be designed by considering the assumptions in 39.1 and the minimum eccentricity. So minimum eccentricity as per 25.4 does not exceed 0.05 times the lateral dimension. So lateral 0.05 times the lateral dimension is 0.05 into 630. So it should not exceed. So it is fine, satisfied, correct? So least lateral dimension I'm getting is 26. Correct. Even this 26 itself is wrong, because அங்க என்ன சொல்லியிருந்துச்சு, either this or it has to be 20 mm. இந்த ரெண்டு தான் ஏதாவது இருக்கணும், not less than 20 mm. So I am taking this 26 and 30 condition satisfied. I am moving on with the strength of the member. So Pu equal to 0.45, sorry, 0.4 FCK AC plus 0.61 ACY. Substitute all the data, you will get the strength of the column. Very simple. If they are asking the working load, divide the factor of safety. Okay, if they are asking the working load, just divide it by factors. That's all. So this is all about analysis part. Moving on with the design part. I hope whatever the steps I have given here, it has been followed. You have calculated the effective length, you have calculated the slenderness ratio, you have checked the eccentricity, load carrying capacity, you have done. That's all. இதோட முடிஞ்சு. இது வந்து analysis part. Design part na you have to calculate the reinforcement, lateral dimension and reinforcement diagram. Right? ஃபார்முலாஸ் எல்லாமே சேம் தான். அதே ஃபார்முலா திரும்ப யூஸ் பண்ண போறோம். நீ வேணா பாரு. நான் ஆல்ரெடி சொன்னதான் LHS RHS மட்டும் தான் நீ கம்பேர் பண்ற. ஒன்னு தெரியும், ஒன்னு தெரியாது. இல்ல இங்க தெரியும், அங்க தெரியாது. இதே ஃபார்முலா தான். சரியா? டிசைன் a column 4 meter long, பொசிஷன் எல்லாமே கொடுத்துட்டாங்க. See, they are given the axial load. ஸோ லோடு கொடுத்துட்டாங்கன்னா நீ என்ன கண்டுபிடிக்கணும்? சைஸும் லோடு கொடுத்துட்டாங்கன்னா சைஸும் reinforcementம் கண்டுபிடிக்கணும். See here, load is given, grade of material is given, you have to find the size and you have to find the reinforcement. இதுதான் வந்து design of column. See the same procedure, effective length is calculated, slenderness ratio is calculated. Here they are assuming the percentage of steel as 1%. You know how much you have to assume. It is there in the code book. 0.8 ல இருந்து 6% வரைக்கும் நீங்க assume பண்ணிக்கலாம். It may be any number, 1 or 1.2, 1.5, 2, 2.5. It's up to you, right? இதெல்லாமே நம்ம நோட்ல போட்டிருக்கோம். ப்ளீஸ் just have a look into your classwork note or the problem that I have sent you already. போட்டிருப்பீங்க. Again, this is why I have asked you to submit the assignment in column, but nobody have done this. Okay, no problem. Past is past. So from I am assuming 1% of steel of the gross area. Gross area ல 1% I am assuming it's a steel. So அப்போ கான்கிரீட் என்னவா இருக்கும்? கிராஸ்ல இருந்து ஸ்டீலை மைனஸ் பண்ணிட்டா கான்கிரீட். ஸ்டீல் என்னது? 1%னா 1/100 0.01 AG. அப்போ இது என்ன வரும்? 1 AG minus 0.01 AG will be 0.99 AG. Just substitute and you will get the gross area. சைஸ் தானே கண்டுபிடிக்கணும்னு சொன்னேன். சரியா? சைஸ் தானே கண்டுபிடிக்கணும்னு சொன்னேன். சைஸ் ஆஃப் த காலமை கண்டுபிடிச்சாச்சு. நெக்ஸ்ட் சைஸை கண்டுபிடிச்சிங்கன்னா அடுத்தது தென் கோ வித் தி eccentricity and reinforcement. Reinforcement ஆல்ரெடி 1% போட்டேன். ஸோ 1% ஆஃப் கிராஸ் ஏரியா எவ்வளோ வருதுன்னு பாரு, 2500. 2500 எவ்வளோ பார் ப்ரொவைட் பண்ணலான்றதை நீங்கள் டிசைட் பண்ண போறீங்க. அவ்வளோதான், சிம்பிள். ரைட். த மோஸ்ட் இம்பார்ட்டன்ட் பார்ட் ஹியர் இஸ் லேட்ரல் டைமென்ஷன்ஸோட என்ன எடுக்கணும், என்ன வரணும்னு கோடு என்ன சொல்லியிருக்கு அப்படின்றத பார்ப்போம். இது வந்து டிசைன் ரெக்குவயர்மெண்ட்ஸ்னு கொடுத்துருப்பாங்க காலம்லேயே. Kindly be with me. Yes, here it is. நம்ம நேற்று பார்த்தோம் இல்லையா, ஸ்லாபுக்கு எங்க கொடுக்கணும் அப்படின்னு சொல்லி என்ன கொடுத்துருப்பாங்கன்றது. அதே மாதிரி தான் அது கீழேயே they are given it for columns also. ஸோ longitudinal section, longitudinal reinforcementன்றது மெயின் பார், வெர்டிக்கல் இருக்கிற பார் அது எவ்வளோ இருக்கணும். இப்போ நான் சொன்னேன் இல்லையா 0.8லேருந்து 6க்குள்ளே எதை வேணா எடுத்துக்கலான்னு. ஸோ அதுதான் அவங்க கொடுத்துருக்காங்க. தென் ஆல் த ஸ்டெப்ஸ் they have given. and if you go transverse reinforcementல பார்த்தீங்கன்னா pitch and diameter of the lateral ties அப்படின்னு இங்க கொடுத்துருப்பாங்க. இதை தான் நீ கண்டுபிடிக்க போற. 3 கண்டிஷனை செக் பண்ண போற. ஒன்று 300 mm, இன்னொன்று 16 times the smallest diameter that you have used for the main bar, and least lateral dimensionோட least lateral dimension எதுன்னு பார்த்து அதோட டைமென்ஷன் என்னன்றதை எடுத்துக்கணும். அதுதான் இங்க சொல்லியிருக்கு. ஸோ 1/4 of the main bar, இங்க main bar 20 யூஸ் பண்ணியிருக்காங்க. ஸோ 1/4 into 20 5 mm. done. Right? So 6 mm diabar யூஸ் பண்ற முடிஞ்சிச்சு. 3 கண்டிஷன் 16 times diabar, 48 times D and 300 mm. இதுதான் வந்துட்டு என்னோட spacing of the lateral dimension ஓட condition. Spacing of least lateral dimension. This part is given here. Spacing எல்லாமே இங்க கொடுத்திருக்கு. Here it is 1, 2 and 3. Right? Is it clear? Just follow this and substitute. You will get done. Then you have to draw the reinforcement diagram. Reinforcement diagram I will show you from the book itself. If they have given, I will show it from the book. Yes, here you can see the reinforcement diagram, how it has to be. So 600 into the dimension, 400 is dimension, and the bar dot இருக்கிறது தான் main bar. So that is 4 numbers of 25 diabar. இந்த சைடில் சுற்றி கட்டியிருக்கிறது தான் இவனோட டைஸு. ஸோ அது என்னன்றது தனியாக யூ ஹவ் டு மென்ஷன். ஸோ டைஸ் இங்கே போட்டிருக்க பாரு, டைஸ் 8 mm டைஸ் 300 mm சென்டர் டு சென்டரில் கொடுத்துருக்காங்க. ரைட், வெரி சிம்பிள். த சேம் ப்ரொசீஜர் வில் பி ஃபாலோட் ஃபார் யூனிஆக்சியல் ஆல்சோ. Again, you see the problem here, design problem. the bottommost part. Design the longitudinal and lateral dimension. Design அவ்வளவுதான். டிசைன் தான் வேற மாதிரி சொல்லியிருக்காங்க. அந்த ஏஎஸ்டியை தான் லாஞ்சிடியூனல் ரீஎன்ஃபோர்ஸ்மெண்ட் சொல்லியிருக்காங்க. லேட்டரல் ஸ்பேசிங் தான் லேட்டரல் ரீஎன்ஃபோர்ஸ்மெண்ட் சொல்லியிருக்காங்க. சரியா? ஸோ சைஸ் ஆஃப் த காலம் கொடுத்தாச்சு. ரைட். அல்டிமேட் லோடு கொடுத்துட்டாங்க, அல்டிமேட் மூமெண்ட் கொடுத்துட்டாங்க. ஸோ 1.5 மல்டிப்ளை பண்ண வேண்டிய அவசியம் இல்லை, நேராக கொடுத்துட்டாங்க. சரியா? ஒரு மூமெண்ட் தான் கொடுத்துருக்காங்க. அப்போ யூனிஆக்சியல் பெண்டிங். ஓகே ஃபைன். ஸோ ஜஸ்ட் டைரக்டாக யூ கேன் கோ வித் தி நான் டைமென்ஷனல் பேராமீட்டர்ஸ். ஓகேவா? நான் டைமென்ஷனல் பேராமீட்டர்ஸ் யூ கேன் டைரக்ட்லி கோ ஃபார் PU by FCK. ஓகே, யூனிஆக்சல் பெண்டிங்கில் இங்கே எதை நீ டிசைட் பண்ண போகிறன்றது இது எக்ஸ்பிளைன் பண்ணிடுறேன். இதுதான் ரொம்ப முக்கியம். கொடுத்த கண்டிஷன் பாருங்கள், என்ன கண்டிஷன் கொடுத்துருக்காங்கன்னு. சாரி கொடுத்துருக்கிற கிரேட் ஆஃப் மெட்டீரியல்ஸ் பாருங்கள். என்ன கிரேட் ஆஃப் மெட்டீரியல்ஸ், அதாவது ஸ்டீல் என்ன கிரேடுன்னு பாரு. 250 இருந்தால் இங்கே மேலே ரைட் கார்னரில் இருக்கும் கிரேட் ஆஃப் மெட்டீரியல். ஃபஸ்ட்டு அதை தான் நீ பார்க்கணும். பேஜ் ஸ்டார்டிங்கே அதுதான். ஸோ மேலே முதல்ல என்ன கிரேடுன்னு பாரு. 250னா என்ன கிராஃபு, 400னா 415னா என்ன கிராஃப்ன்றது தெளிவாக பாரு. அடுத்தது D dash by D. Okay, D dashன்றது cover. What is the cover for column? What is the cover for column?
40 mm.
Okay, you can assume it 40 and 50. No problem. Anything is fine. So D dash by D போடு. What you are getting? 0.05 இல்லை 0.10 அதை பொறுத்து டேபிள் மாறும். ஃபர்ஸ்ட் செக் பண்ண வேண்டியது ஸ்டீல் கிரேடு, அடுத்தது D dash by D, அதுக்கப்புறமா PU by FCK and MU by FCK. Pன்றது லோடு கொஸ்டின்ல இருக்கு, FCK இருக்கு, B இருக்கு, D இருக்கு. Mன்றது மொமெண்ட் இருக்கு கொஸ்டின்ல, FCK, B இருக்கு, D இருக்கு. ரைட். ரெண்டையும் கால்குலேட் பண்ணி இது ரெண்டையும் எங்க ரெண்டும் கார்லேட் ஆகுதோ அதை எடுங்க. அந்த பார்ட்ல அங்க கிடைக்கிற வேல்யூ தான் இங்க இருக்கு, P by FCK. சரியா? P by FCK. Here you can see. Okay, I'll show this one. Return itself. Okay, so P by FCK தான் இதோ here you can see. இதை வச்சு P by FCK BDலேருந்து என்ன வேல்யூ, MU by FCKல என்ன வேல்யூ, D dash by D என்னன்னு போட்டு அதுலேருந்து you can just calculate what is your P by FCK. I'm getting 0.06. ஸோ அந்த FCKவை இன்ட்டு மல்டிப்ளை பண்ணிங்கன்னா 20, I'm getting 1.2%. ஸோ PTன்றது 100 ASC by BDன்னு உனக்கு தெரியும். ஸோ I'm getting 2400. ஒன்ஸ் இது கிடச்சிச்சுன்னா பார் அசியூம் பண்ணு, எத்தனை பார்ன்றதை அத்தனை பார் கொடு. அவ்வளோதான், சம்ம முடிஞ்சிச்சு, இதோட ஓவர். இதுக்கப்புறம் லேட்டரல் ட்ரைஸ் நான் ஆல்ரெடி பண்ணதே தான். ஸோ ஒன்றும் சேஞ்ச் இல்லை. இன் அடிஷன் டு லைக் நார்மல் ஆக்சியல் டிசைனுக்கு யூனிஆக்சியல் டிசைனுக்கு. ரைட். பைஆக்சியலும் இதே தான். ரெண்டு டைரக்ஷன்ல யாட்டுக்கு விதி வாட் இஸ் தட் ரீஎன்ஃபோர்ஸ்மெண்ட். ரைட். மொமெண்ட் ரெண்டு டைரக்ஷன்லையும் இருக்கும், ரெண்டு பக்கமும் நீ செக் பண்ணணும். அதுக்கு தான் இந்த ஃபார்முலாஸ் கொடுத்துருப்பாங்க. MUX by MUX1 alpha n plus MUY by MUY1 alpha n greater than or equal to 1.0. Right. So this particular part, that is biaxial bending alone, will get more time because you have to refer 2 to 3 charts and the load will be higher. You have to calculate PUZ also, right, which will be covered as a separate topic. So no need to brush up here. So I hope uniaxial bending and axial compression part is clear for you. காலம்னா என்ன, வாட் டைப் ஆஃப் காலம் இருக்கும், கொஸ்டின் என்ன இருக்கும், ஐ வில் ஷேர் திஸ் ஸ்லைட். ஸோ ப்ளஸ் ஜஸ்ட் அண்டர்ஸ்டாண்ட் அண்ட் கோ வித் தி ஃப்ளோ. இஸ் தட் கிளியர்? டூ யூ ஹாவ் எனி clarification on this uniaxial and analysis part? Yes or no? Is it clear? Good to go?
Yes, sir.
Yes.
Fine. Okay.